Maximizing game performance, proven tips and techniques for faster games. Hey fellow game devs and gamers, it's your buddy Mr. Dev, and today we'll be talking about the thing that might make or break your indie game, that's performance optimization. So all of us indie devs, we want our games to look amazing and run smoothly at the same time, but how do we achieve that without sacrificing too much? Well, let's take a look at some of the essential tips for game optimization. Firstly, let's talk about draw calls. Draw calls is the number of times a graphics engine has to call to render a particular object. The more draw calls you have on your scene, on your screen, the more strain you put on your system. So what can we do to optimize those draw calls, to minimize the number of draw calls and improve performance? Well, one trick we can use is material merging. Material merging is combining multiple meshes that share the same materials into a single mesh. In that way, you will reduce the number of draw calls needed to render a particular object. So I'm gonna give you an example, guys. For example, you have a pile of garbage bags in one single place, and each one of those garbage bags is separate mesh. You can select all of those garbage bags and merge them into a single mesh. So in that way, instead of having draw calls for every single garbage bag, you will have only one draw call for the entire mesh. Next up, we have texture optimization. So textures play a huge role in the game development world in video games, but they can take a lot of memory. So one thing we can do with those textures is reduce their resolution and trim them down to their minimum required resolution. I'm gonna give you an example. Like, you have a lighter that the character holds in his hand, and that lighter is never brought in a close-up shot. That means that that lighter doesn't need to have a 4K resolution, and you can freely lower the texture resolution of that lighter. Now let's talk about occlusion culling. Now this is where objects which are not visible to the player, they're not on the screen at that particular moment, they're not rendered. So by doing this, we will reduce the number of draw calls and at the same time improve performance. Another cool thing that a lot of game developers, a lot of experienced game developers do is to turn off the shadows on particular foliage. So foliage can be quite heavy on the GPU and can impact your game's performance, and by turning the shadows off, it will vastly reduce the number of draw calls and improve performance. But be careful, you don't need to turn the shadow on everything that is foliage. You can turn off on some particular things like grass, but you can keep the shadows on the trees. Another technique we can use is texture atlasing or atlas mapping, which is a technique where multiple smaller textures are combined into a single larger texture. And this way, this texture is more efficient for the GPU, it reduces the number of draw calls and provides better performance for the game. For example, if you have a lot of smaller props on a table and they have a separate textures, you can always merge them into a single larger texture and they will share the same material, and in that way you will improve performance and reduce the number of draw calls. But wait, it's not just about texture optimization. There are other ways and techniques you can use to optimize the overall gameplay performance. For example, we can use LODs or level of detail, and those are lower quality meshes of the same mesh that you use in the game engine and are switched by the game engine once that object is further away from the player camera. For example, you can have a statue that is 30,000 faces, 30,000 triangles, and when you get a little bit further away from the statue, it will switch to a mesh that has 20,000 faces, and when you go very far away, it can be like 5,000. So all of these will improve the overall performance of the game. Another technique we can use is instancing, where multiple instances of the same object are rendered at once. This technique greatly reduces the number of draw calls and is particularly useful for objects that are repeatable throughout the game world, such as trees and rocks, etc. Let's not forget about audio optimization. So audio can take up a lot of memory, especially if you use a lot of sound effects and music tracks in your game. So by compressing those audio files and reducing the number of channels, you can improve the overall performance and reduce the footprint they have on the overall memory. Now let's talk about the programming part. Avoid redundant calculations. Avoid calculating the same thing over and over again, and instead store the result of your calculation in a variable and use that variable in all subsequent calculations. Use object pooling. Object pooling is a technique where you reuse objects instead of creating new ones every time you need them. So this can significantly reduce memory usage and improve performance. Another thing we can do is limit the number of loops. Loops can be slow, especially if they're iterating over a large number of objects. So instead of using loops, we can always use built-in functions or methods to improve the overall performance. Don't use for loops all the time that go through infinitely large arrays. Use data structures efficiently. Make sure you're using the appropriate data structures for your needs. For example, if you need to search through a large data set, a hash table or binary search tree might be more efficient than a simple array. And lastly, we'll talk about call distance. Call distance is the distance at which objects are no longer rendered. By setting up reasonable call distance, we can greatly reduce the number of draw calls and improve the overall performance. This technique is especially useful if you're creating an open world game. So the way you can do it is by setting up manually the call distance value in every single mesh, or you can use call distance volume in your game world if you're Unreal Engine 5 user, not really sure about Unity, but in Unreal you can always set up a call distance volume and set up those values. So one example of call distance, the best example I remember is Silent Hill, where they use the fog to hide the call distance working and the disappearing of models to improve performance. Overall, optimizing your game's performance can be a daunting task, but it's essential for a great player experience. By utilizing these tips and tricks, we can maximize performance without sacrificing too much in terms of graphics. So remember, as indie devs, we don't have the same resources as AAA studios, but with some persistence and creativity, we can create amazing games that run smoothly. Remember, optimization is an ongoing process. It's not something you do once and forget about. As you add more content to your game, you'll need to keep optimizing to ensure it runs smoothly on a variety of hardware configurations. Well, that's all for today, folks. If you have any other optimization tips, please make sure to leave them down in the comments. As always, please leave a like and subscribe to the channel for more game dev content like this. This is Mr. Dev signing off.